Good afternoon everyone. My name is Dr. Saurabh Roy. Welcome you all in the lecture series of electromagnetic waves and transmission line. So in the last lecture we discussed about the Coulomb's law as well as we have seen the electric field, how the electric field lines are there. Now in this lecture we will discuss about the electric field intensity and also we will calculate the electric field intensity for an infinite line charge. Okay, which density is rho L. So in the last lecture we just revised the things. What is Coulomb's law again? So it states that the force F between 2 point charges Q1 and Q2, it depends on along the line joining them, directly proportional to the product of the charges as well as inversely proportional to the square of the distance between them. So we can write down F equal to K Q1 Q2 divided by R square, where Q1 is charge on mass 1. Okay, Q2 is charge on mass 2, R is the distance between two charges and K is the Coulomb constant. So that is the Coulomb's law. The force between 2 point charges Q1 and Q2 along the line joining them, directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay. We also represent in vector form also, F equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R cube into R vector. Okay. So now what are the electric field lines? We already discussed in the last lecture. We just revised the things. If lines will comes out from the positive charges and it goes inside in the negative part. So here field lines point toward negative charges and away from the positive charges. So those are the things. If it is both are positive charges, then how the field line will be look like. If both are negative charges, how the field line will be look like. And if positive and negative both charges are there, how the electric field lines are look like. Okay. So that is visible there. Now if the another things, if now we will discuss about the electric field intensity, means whenever any charges kept or whenever any charges comes to the electric field lines which is generated by some charges. Okay, so what are the effect, how much force he will experience, so that is called electric field intensity. So how the electric field intensity, the force per unit charge when it is placed in a electric field. So if here we will see if this charge is unit charge is there, then how much force he is experienced, so that is called electric field intensity at that particular point. So force per unit charge when it is placed in an electric field. Okay, so that is the definition of electric field intensity. So whenever any charge or unit charge comes to place in an electric field, it is seen there, then we can find out that is called electric field intensity. Okay, so it can be represent E equal to F by Q. So we already find out that F equal to 1 by 4 pi epsilon naught Q1. So here Q1 and Q2. So Q2 value will be 1. So that's why 1 by 4 pi epsilon naught Q1 R minus R1 cube into R minus R1. Okay, so that is the electric field intensity, the force per unit charge when it is placed in an electric field. Now coming to this point, so if multiple forces are there, so due to this multiple charges Q1, Q2, Q3 and Q4, what are the electric field intensity at particular point P? Okay, so here charges is there Q charges, so Q will become here, Q will become 1. Okay, so the electric field intensity at Q point, the force per unit charge when it is placed in an electric field. So here how many charges are there? 4 charges are Q1, Q2, Q3 and Q4. So due to these 4 charges which is placed in, or we can display R1, R2, R3 and R4. So those are the vectors we are considering in Cartesian coordinate system. Now total force due to these things, we know total force F equal to 1 by 4 pi epsilon naught Q1 divided by R minus R1 whole cube into R minus R1. Similarly Q2. So now Q will become 1. So the electric field intensity will become 1 by 4 pi epsilon naught Q1 divided by R minus R1 whole cube into R minus R1 plus 1 by 4 pi epsilon naught Q2 divided by R minus R2 whole cube into R minus R2 plus 1 by 4 pi epsilon naught Q3 divided by R minus R3 whole cube into R minus R3 plus 1 by 4 pi epsilon naught, this will become Q4 divided by R minus R4 whole cube into R minus R4. Okay, so this is Q4 actually. Okay, so see so here instead of in force we are placing So here q1 will come, but here this q value will become 1. Okay, so the force per unit charge when it is placed in a electric field. So here electric field is generated by q1, q2, q3 and q4. So total force experienced by this unit charge is called electric field intensity. Now we have seen the electric field due to the continuous charge distribution. Okay, now we will see if it is point charge, we can find out E equal to 1 by 4 pi epsilon naught q1 divided by r minus r1 whole cube into r minus r1. So q1 will become 1. Now if it is line charges, then we are considering continuous charge distribution. So line charges, there is Royal charge is distributed throughout that particular line. Similarly, here's ρs, surface charge density is ρs. So that is all point or uniformly distributed. The charges are uniformly distributed through the surface. So here line charges means Royal line charge density means every line this uniformly distributed throughout the line. Okay, so first we will see point charges, already we have seen. Now line charges, this one is surface charges, another one is that is called volume charges. So in a particular volume it is distributed, the charge is uniformly distributed. Now due to distance r, what are the electric field intensity? For line charges, so Royal dl divided by 4 pi epsilon naught r square air, E equal to ρs ds, that is the surface integral 4 pi epsilon naught r square air, E equal to ρb dv 4 pi epsilon naught r square air for volume. Okay, so this q equal to q total charge due to this line charges, q is Royal integration of Royal dl. Okay, so q divided by 4 pi epsilon naught r square air for a certain point which is distance r, the electric field intensity due to this line charge. Similarly, for surface charges, E equal to surface integral ρs ds. So surface integral ρs ds means that is the q total charge of particular this surface. Similarly, this total charge particular this volume, q equal to ρv dv. So we are getting E equal to q divided by 4 pi epsilon naught r square. Okay, so this is the electric field due to continuous charge distribution. So we will see for line charge as well as surface charge as well as volume charge. So line charge density is Royal, surface charge ρs, and volume charge density is ρb. Now we will calculate electric field for a line charges intensity for a line charges in a certain particular point P. So here we are considering this one is a Cartesian coordinate system which is represented in x, y and z. Okay, now one line we are placing in z axis. Okay, so in the line charge which has Royal is line charge density which is uniformly distributed throughout this particular line, so it is placed in the z direction. So now for this particular line we will calculate the electric field intensity at a point P. Okay, so we know the formula is which has distance r. We know the electric field intensity due to this line charge, already we have seen last slide, E equal to Royal dl divided by 4 pi epsilon naught r square into air. Okay, so these dl charges total, so total line, if you are considering this particular, then integration of Royal dl 4 pi epsilon naught r square air, where Royal is the line charge density, this Royal is the line charge density, r is the distance vector between P and this small dl. Okay, so we are considering this small dl. If we will find the integration from this point to this point, so totally we can find out the electric field intensity. So that is Royal dl divided by 4 pi epsilon naught r square. Okay, so this is the work. So we are considering a Cartesian coordinate system. So there is, we are placing a line, and due to this particular line at P point, what is the electric field intensity? Okay, now so we are considering this another point, that is this point. This point is in this, whenever P is extended this particular line or yellow color dotted line, so in the z direction we will get 0 0 z, which is distance from origin to particular this point is z point, and this particular point to this row, this P point, the distance is rho, where rho equal to root over x square plus y square. Okay, so here we are considering one point which is which is touches this particular point, and we are making a triangle in between this particular area. So the angle between this particular point, the angle between this rho and this angle is called alpha. So angle between this particular point and this point. So what are the distance between these 2 points? Okay, so we know that the dl vector is 0 0 z bar dl coordinate. So from distance from this origin to this particular point, distance is z dash. So distance between this particular 2 point equal to z minus z dash, means this one minus this particular point. So z minus z dash we will equal to rho tan alpha. We know. Okay, so z dash minus z divided by rho equal to tan alpha. So we will get z minus z equal to rho tan alpha. Okay, so we can. So now our this E equal to, we know, rho L divided by 4 pi epsilon naught dl by r square into r. Okay, so z minus z dash we know rho tan alpha. Okay, so our these things, rho L is the volume, line charge density is constant quantity, so we can kept outside. 4 pi epsilon naught is also constant, we can kept outside. So integration of line integral r dl divided by r cube. Okay, so this unit vector we can represent this r vector divided by magnitude, where r is the vector and this one is the r cube is the this r is the magnitude. Okay, white color. Now dl we can write down this dl by dl, this it is in z direction. So dl we can mention dl is dz bar. So for finding this particular integration we should put the value of r, dl and r cube. So first we will start from dl. So dl is dz bar because it is bearing in z direction. So this point is dl. So dl is dz bar. So we can consider dl equal to gz bar. So we know z minus z bar equal to rho tan alpha. So dz bar equal to, because z is the constant part, so minus dz bar equal to rho sec square alpha. So dz bar equal to, we can write down minus rho sec square alpha. Now we will find out the value of r. So r is the distance vector between this point and this point. So r equal to, we know this point is x, y, z. So r equal to x minus 0 ax plus y minus 0 ay plus z minus z bar az. Okay, so that is the r vector. Okay, now we can find out the magnitude of r vector equal to root over x square plus y square plus z minus z bar whole square. Okay, so this r vector we can represent as well as this x plus y in Cartesian coordinate system to cylindrical coordinate system. This part will become rho arrow. Okay, so rho phi z. So instead of rho we can use x plus y equal to rho arrow and z minus z bar into az. So z minus z bar, we know what is the value of z minus z bar, rho tan alpha. So we can put down rho arrow plus z minus z bar equal to rho tan alpha az. Okay, so this part is clear. So r vector we are coming x plus y plus z minus z bar az. Similarly x plus y we can say rho arrow plus z minus z bar az, where z minus z bar is rho tan alpha. Okay, so we are getting these two vectors. Okay, now so we know this part E equal to rho L divided by 4 pi epsilon naught. So length we are considering from A to B. Okay, so finite length of this particular O with charge density rho L. So rho L is the constant 4 pi epsilon naught A to B r dl. So you know that r vector is rho arrow plus rho tan alpha az, and dz bar equal to dl equal to dz bar equal to minus rho sec square alpha dl. So one thing is unknown, this r magnitude of r. So magnitude we can r equal to magnitude of r vector equal to, we are getting rho square plus rho square tan square alpha. Okay, so now we will put all those things in this particular equation. So what will be the value? So rho L divided by 4 pi epsilon naught rho arrow plus rho tan alpha az. This is for r vector. This one is minus rho sec square alpha d alpha for dl. So here minus we are keeping it outside, and this one is r cube we can write down rho square plus rho square 10 square alpha, that is q. So we can write down 3 by 2. Okay. So here from A to B, here so A to B we are, because all the things we are representing in angle. So this distance from this row line or particular this plane, so angle is from A point, the angle is alpha 1, and B point the angle is alpha 2. So we are change the limit because all the things are expressed in alpha and angle. So alpha 1 to alpha 2, rho or a rho 10 alpha H8 rho sec square alpha d alpha divided by rho square plus rho square 10 square alpha 3 by 2. Now if we'll reduce this term, so rho L minus rho L divided by 4 pi epsilon naught, this rho square plus rho square 10 square alpha 3 by 2 we can put rho cube sec cube alpha, because rho square we can take common, so 1 plus 10 square alpha will become sec square alpha. So rho square sec square alpha 3 by 2 will become rho cube sec cube alpha. Now we can cut the point, rho square we can cut, sec square also sec cube we will get. So in down we will get rho sec alpha. Okay. So we can represent E equal to minus rho L divided by 4 pi epsilon naught alpha 1 to alpha rho a rho plus 10 alpha AZ rho sec square alpha d alpha divided by rho cube sec cube alpha. So we can cut down this particular part, rho square. So we'll get rho sec square alpha sec cube sec alpha. So a rho plus 10 alpha AZ d alpha minus rho L divided by 4 pi epsilon. So in the next part, this part is the common constant. So we can kept outside rho. Okay. So distance between this axis. Now alpha 1 to alpha 2. So 1 by sec alpha will get cos alpha a rho. 10 alpha by sec alpha. So cos and sec both get cancel. Will get sin alpha h and d alpha. So we are getting minus rho L divided by 4 pi epsilon naught rho a. So cos alpha will become sin alpha a rho. Sin alpha will become minus cos alpha AZ. So alpha 1 to alpha 2. So this is the overall electric field intensity for a finite length. Now we will see the electric field intensity for a infinite length. Okay. So if infinite length means this A point is going to infinity and minus infinity, and B point is going to plus infinity. So if you will see A point will go, then this alpha 1 angle will increase, this angle will increase. So this angle will increase up to infinity. Similarly, B point, if we will extend in this particular direction, positive z direction, then alpha 2 will become increases, or alpha 2 is increased to this angle or direction will change, then alpha 2 will become minus 90 degree and alpha 1 become plus 90 degree. So if we will place the value minus rho L divided by 4 pi epsilon naught sin alpha, so this angle, so we'll get alpha 1 90 degree, alpha 2 minus. So alpha 2 sin alpha 2 means sin minus 90 degree minus sin 90 degree a rho minus cos 90 cos minus 90 minus cos 90 h. Okay. So cos 90 we know 0. So we'll get minus rho L divided by 4 pi epsilon rho sin minus sin 90 means minus 1 minus sin 90 1. Okay. So minus 1 will become minus 2. So we will get rho L by 2 pi epsilon naught rho here. So this is the electric field intensity for a particular P point due to the infinite length charge, which density is rho L. So this is the one typical numerical based example where we are calculating the electric field intensity for an infinite length. So the value will be rho L divided by 2 pi epsilon naught rho. So in the next lecture we will discuss about some other point, Gauss law, what are the application of Gauss law and how we can